Gasoline four-stroke. The engine in most cars runs on a controlled explosion. About 25 of them every second, just sitting at idle. A piston drops and pulls in air and fuel. It rises and crushes them into a space the size of a shot glass. A spark hits, bang, and the blast slams the piston back down. It rises once more and shoves the burnt gas out. Two-stroke. Same explosion, half the steps. It fires every time the piston comes up, instead of every other time. So it makes nearly double the power for its size. That's why it's in chainsaws, dirt bikes, and outboard motors. The catch is how it breathes. Fresh fuel and burnt gas share the cylinder for a moment, and some fuel escapes unburnt. That blue haze, that smell, that's you, literally throwing money out the exhaust. Diesel. Now take the spark plug out and throw it away. A diesel never lights its fuel. It crushes the air so hard, so fast, that the air itself turns hot enough to set the fuel off the instant it sprays in. Pure pressure. Nothing to spark, nothing to fail. Which is why a diesel runs 500,000 miles and outpulls a gas engine down low. It's under every truck, ship, and train you've ever been stuck behind, and it clatters because inside, it really is a chain of tiny, hard detonations. Wankel Rotary. And here's the first one that ditches pistons entirely. No pistons, no up and down, just a rounded triangle spinning inside an oval, and the three gaps around it suck, squeeze, bang, and blow as they sweep past. It's tiny, dead smooth, and screams to 9,000 RPM. Mazda loved it. It also burns oil on purpose and chews through its own seals, which is why almost nobody else builds one. Steam engine. Rewind 200 years. Every engine so far burns its fuel inside the cylinder. Steam burns it outside in a fire under a boiler, and all that fire does is boil water. The steam expands, shoves a piston, and that's the whole industrial revolution in one sentence. Slow, enormous, forever to warm up, but it runs on anything that burns, coal, wood, literally garbage because the flame never touches the moving parts. Stirling engine. Seal a gas inside, heat one end, cool the other, and as it swells and shrinks sloshing between them, that alone drives a piston back and forth. No explosion. No exhaust. No sound. Some are so delicate they'll spin on nothing but the warmth of your hand on the base. Silent. And nearly unbreakable. Which is why it hides inside submarines and spacecraft, where noise or exhaust gets you found. Turbojet. Now everything speeds up. Air pours in the front, a compressor squeezes it, fuel burns in a nonstop roar, and the blast tears out the back, spinning a turbine on the way that drives the compressor up front. It feeds itself. No pistons stopping and starting, just one smooth river of fire. This is the engine that put fighter jets past the speed of sound. Turbofan. Look up at any airliner. This is what's on the wing. It's a turbojet with a giant fan bolted to the nose, and here's the twist. Most of the air that fan grabs skips the fire completely and gets shoved backward around the outside. That cold bypass air is quieter and far more efficient at cruising speed. The screaming jet core in the middle is now mostly just there to spin the fan. Almost everyone watching this has flown behind one. Turboprop. Same jet core, but instead of blasting the exhaust out the back, you bleed nearly all of it into spinning a shaft with a propeller bolted to the end. That's what's on most small regional planes, quieter and thriftier than a pure jet down low. Feed that shaft into a gearbox instead, and you've got a turboshaft. The same engine that flies almost every helicopter and drives the turbine inside an M1 Abrams tank. Scramjet. Go fast enough and you don't even need a compressor. Raw speed rams the air in and squeezes it for you. But past 5 times the speed of sound, that rammed air would slow so violently it'd tear the engine apart. So a scramjet refuses to slow it down. It burns the fuel while the air is still howling straight through faster than sound. Combustion inside a hurricane in a window a few thousandths of a second wide. It's how you'd cross an ocean in under an hour. Pulsejet. It's barely more than a pipe with a flap on the front. Air gets in, fuel lights. The blast slams the flap shut and fires out the back. Then the flap flops open and it does it again, 50 times a second with a sound like the devil's own lawnmower. The Germans bolted one to a flying bomb in 1944. and people beneath its path learned to dread the buzzing and to dread the silence even more, because silence meant it had stopped and started to fall. Solid rocket, a tube packed with rubbery fuel that already has its oxygen mixed in. Light the top and it burns down like a firework the size of a building. Once it's lit, it burns till it's done and you're just along for the ride. Those are the two boosters strapped to the space shuttle. Liquid rocket. Two liquids, a fuel, and pure oxygen to burn it, pumped into a chamber and lit, making an explosion you can throttle, steer, and switch off. That control is the whole game. It's the difference between a firework and a machine that lands itself back on the pad, upright, balanced on a pillar of its own fire. Everything that has ever carried a human off this planet rode one of these. Ion thruster. It takes a gas, strips it into charged particles, and flings them out the back on an electric field in a faint blue whisper. The push is almost nothing, less than the weight of a coin resting on your palm. But out in the vacuum, there's nothing to slow it, so it just keeps pushing, day after day for years, quietly winding a probe up to speeds no explosion could ever reach. Patience as a form of power. Electric motor. An engine burns fuel, a motor just runs on electricity. No combustion here, no heat, no bang. Just magnets and current spinning a shaft with almost no moving parts and almost no noise. But it out-accelerates nearly everything above it from a standstill, which is why the fastest cars on Earth are quietly going electric. Nuclear pulse. In the 1960s, real engineers seriously designed a spaceship that moves by dropping atomic bombs out the back and detonating them, one after another, against a giant steel plate on shock absorbers. Each blast kicks the whole ship forward. It sounds insane. It also would have worked, and it's still the only known way to push something the size of a city to another star inside a human lifetime. They shelved it because setting off hundreds of nuclear bombs in the sky turned out to be, understandably, illegal. Antimatter. Everything else on this list wastes most of its fuel. A little becomes motion. The rest is lost as heat and noise. Antimatter wastes nothing. Bring 1 gram of it together with a gram of ordinary matter, and both vanish entirely into pure energy, the most violent conversion the universe allows. A few grams could carry a ship to another star. The only catch is making it. That single gram would cost more than every economy on Earth combined.